afternoon, everybody. Can you hear me? I'm mic'd up. Yeah, that's great. So thanks for coming along before your lunch today. I'm going to speak a little bit about Ireland's energy statistics, projections, and targets. I'm going to make the talk as interesting as I can. And please do, as we're going along, if you have an inline question or a question in real time, stick up your hand, and I'll try and respond as quickly as I can. At the end of the talk, there'll be a roving microphone going around as well. So plenty of opportunities for you to ask questions, dig a little bit deeper, and I'll try and go into things as quickly or as in as good detail as I can. So this is a bit of a tasting menu of what we're going to do today. We're going to speak a little bit about how energy data is collected, where data comes when we're talking about past data, present data, and future data related to energy and climate. We're going to look at how we turn that raw data into measurable results that can be kind of correlated to targets and give a success or a failure against those ambitious targets. Specifically, we're going to look at emission targets, and we're going to look at renewable energy targets. So the national emission targets and the European renewable energy targets. And we're going to speak a little bit about how in SEAI we're moving to supplement national statistics with regional statistics and ultimately community statistics, so that we develop numbers that speak to policy, planning, and people in Ireland. So the first thing I'm going to speak about now is just the important differentiation between past numbers, or past data, and future numbers. So in SEAI, we measure the past data. So we know what happened in the past by measuring it, and then we have very, very bright people who do modeling and projections to give a best estimate of how those numbers will develop and evolve into the future. That's split across two teams in SEAI. I head up the energy statistics team. Emma Lynch, my colleague, heads up the modeling team. And we're mandated by the SEAI Act to produce national energy statistics. So we have this kind of firewall distinction in SEAI between past numbers and projections, because we never want people to mistake a measured value with a projected value, because one is the best estimate that we can make given the available data, and the other is a best estimate of the future given the data that we have looking forward into the past. So my team look at two different types of past data. The definitive past, so this is our gold-plated annual surveys. We do an awful lot of reconciliation of data with the EPA, the CRU, the CSO, and that means that about 1 year or 18 months after the fact, we have gold-plated data on energy emissions, energy renewability, the supply and demand of energy. We're also working very hard at the moment to leverage strongly our monthly data. So we've got fast-paced monthly surveys that kind of give us a provisional estimate of how the year is doing. And then we hand over to Emma Lynch and her team in the modeling group, and they project the future out. So that's really how we kind of have that full transition of past to present to future data in SEAI. That data is freely available on the SEAI website. We have an energy portal, and you can access both the past and the future data there in terms of primary energy, final energy, CO2, from again, both the measured past and the projected future. So before we kind of can turn all that wonderful data, that raw data, into real results and measure those results against the target, we have to do a fair bit of energy accounting. That's really what the stats team do. And it's kind of important to realize that when you start talking about the carbon budgets or the national emissions, energy is a very, very significant player. So 57% of all greenhouse gas emissions in Ireland come from energy, but it's important to realize that 100% of the electricity, transport, residential, and commercial emissions come from energy. So it's fair to say that 57% comes in average, but in certain sections, it's all energy. So if you don't have really good energy accounts, energy statistics, you're going to have bad carbon accounts and statistics. That's why we spend so much time working on the definitive analysis and making sure that the results are really gold-plated, because they fall into legally binding targets. They have a cost to the exchequer if these targets aren't met, so the numbers have to be very, very good. We also use the SEAI data to satisfy European reporting obligations. So there's an awful lot of attention in the media, quite justifiably, around carbon budgets and national targets, but our European targets haven't gone away. So we have strict renewable energy share targets for Ireland around transport, heat, and electricity, and an overall result. And there's also a binding energy efficiency directive as well that kind of puts limits on how quickly Ireland's energy demand can grow. So the data that the SEAI stats team generate satisfies these international reporting obligations. So in order to pull all the data we need to satisfy these reporting obligations and also to inform the EPA's greenhouse gas inventory, which feeds into the carbon budgets, we have to look at Ireland's energy through several different lenses. So we look to see where and what energy is coming into Ireland. Are we producing energy ourselves? Are we importing it? Are we exporting it? What type of energy are we importing and exporting? We also look at who is using that energy through fairly detailed sectoral analysis. We look at 36 different sectors or slices of the Irish economy to really understand where the energy is being used, and therefore that we can kind of devise policy recommendations which would target the decarbonisation of energy within those subsectors. And we also do what's termed modal analysis of the energy. So not only what energy is being used, where it's being used, but it's how it's being used. So how much electricity is industry using? How much heat is the residential sector using? Because the decarbonisation strategies for electricity, heat, and transport are very different. And so we don't want to muddle all the numbers together. It's important that we understand those equally well and kind of devise decarbonisation strategies appropriate for the mode. So I'm going to quickly show up a bubble plot here, which will help explain the what and the where of Ireland's energy. So it explains where our energy is coming from. Is it coming from indigenous production, imports, or exports? And it does the high-level breakdown of what different types of energies are being used. So a plot like this is quite useful because some things just immediately jump off the screen in a way that maybe if I put up a table of numbers, they wouldn't. And something here that is often surprising to people is just how much oil and gas we import. So when we have a look at the ratios of indigenous production to import to exports, I'll just check my notes so that I get it actually right. So Ireland imports 78% of its primary energy. So 78% of the energy that we need in Ireland comes from abroad, so that we're only producing the 22% indigenously. And I'll check my notes again. So 89% of our imports are actually coming from oil and gas combined. So these are real sectors. They're full fossil fuels, and they make up the lion's share of our imports, and our imports make up the lion's share of our energy demand. So there's a very, very considerable fossil fuel dependency still in Ireland, still today. And that's really what we're trying to understand so that we can move away and move in towards more renewable sources. We import about 3/4, I think it's 73% of our natural gas. It's going up to 75% in 2022. And that import dependency of gas is increasing all the time as the output from the Corrib gas field reduces. So again, we're seeing increased energy dependency in some sectors, and that has knock-on effects for our security of supply for electricity, natural gas, etc. So I know that DEC is running kind of a review and a public consultation on energy security at the moment. I think they published the preliminary results on the website. So if you're interested in energy security, I'd really encourage you to have a look there. Interestingly, 2021 was the first year in which we actually produced more renewable energy than gas. So we are seeing that the transition is there. It's small, it's slow, but it is coming down the line. But it's interesting to look at this kind of purple dot on the screen and just see that's all of our renewable energy and kind of get a feel for what that looks like compared to the other energy supply sources we're depending on. Last year as well, we produced about 12 times as much renewable energy as we did peat. So again, this transition away from indigenous production of energy from peat and towards renewable energy is well developed and is only accelerating as we go forward into the future. So really, what I've shown there is primary energy. It's raw energy. It's things like crude oil or it's gas before we burn it in electricity power plants to generate electricity. So in SEAI as well, we do the like farm to fork or bean to cup. So we look at the primary supply of energy from crude oil all the way down to the blended fuel that goes into your car. So what we have is the primary energy supply. It undergoes a number of energy transformations, again, turning it from like raw energy into a finished product for final demand and final consumption. And along that journey, there are some losses. So no process is 100% efficient. And as you're pushing electricity around the country to the grid, there are heating losses and induction losses, etc. But this is a kind of a simplified map to show just really a little bit about how maybe electricity goes through transformation. So we have a number of different channels going in. So when we look at electricity generation, we take in coal, peat, natural gas into our public thermal plants. We also have CHB, or combined heat and power plants. We also have wind, solar, hydro, etc. So really, the job of SEAI is to try and account for all these inputs, outputs, transformations, and losses to have that really, really definitive energy data at the end of the year that we can provide into the national statistics and into the results. We also take account of the losses, both in transformation and distribution, and in final demand. So we have this real, again, farm-to-fork understanding of energy in Ireland, broken down by 36 fuel types and 33 sector demands. So we've got, when you do the maths, it's almost 1,000 nodes of information that we have where energy is being used, when, and how. So this is a little bit about, again, understanding that map. So previously, we've shown where energy has come from, but now I'm going to show who is using energy in Ireland. So this is a high-level sectoral breakdown. And again, hopefully on this nice bubble plot, some things jump off the page. I'd expect the first thing would be just the huge dependence of transport on oil. So 95%, even today, of all transport in Ireland is oil. And I don't mean blended oil product up from the forecourt. I mean petroleum product that comes out of the ground before blending. That's trains, planes, automobiles, for anything that's used for moving people or goods around the country. And it is by far the largest kind of subsectoral breakdown. The other interesting thing is that oil permeates the entire economy. So while oil dominates transport, you can kind of see here that oil is everywhere. It's in industry, it's in residential, it's in comm services, public services, agriculture, etc. So it's particularly important that we address it, and we need different strategies to move oil consumption out of different sectors. And that's really why the different policy and climate action, the action points in the Climate Action Plan look to provide this granularity. So it's not one problem. It's a challenge that's spread and is different in different sectors, and it needs to be addressed appropriately. Sorry, this is me just again looking at transport. But I'll stick with the main point that 95% of transport is currently raw petroleum product. In the residential sector, it's another interesting problem because the residential sector uses everything. So again, there's coal, peat, oil, gas, renewables, electricity in the residential sector. So there's no single solution for moving that out. We need to have a kind of a nuanced suite of resources to try and decarbonize the residential sector. The obvious ones will be moving away from oil and natural gas and towards electricity by replacing gas and oil burners with heat pumps, etc., and reducing the actual overall demand in the residential sector by increasing the building standards and through retrofits. And that's probably a key point here, is that about 64%, so almost 2/3 of all energy demand in Ireland is in people's homes or in vehicles. And that's why the vast majority of SEAI's suite of supports tackle home retrofit or upgrade, and also tackle grants for EVs and EV chargers. Because if you can solve those problems, you're kind of solving 2/3 of the energy demand problem. So decarbonization of the transport and residential sector is very, very important. Having said all that, I do want to say that there is plenty of light at the end of the tunnel. We are seeing increasing amounts of renewables. So renewable energy is, like oil, is permeating all sectors of the economy. We're seeing significant direct use of renewable energy in the industry and transport sectors. In transport through biofuels, in the industry through the use of biomass for heating and processing. And electricity, which also is a cross-cutting energy source across all sectors, is increasingly renewable. So I'm not sure if it comes across well in this presentation, but about 40% of the electricity that comes out of every socket in the country is renewable. And that number is going up all the time. It should be up at about 80% by 2030. So there's this kind of rising tide lifting all boats. So as the electricity in the grid gets more and more renewable, every action at home or energy use at home that uses electricity just inherently becomes more renewable without any real effort or behavior change from people using the energy source. Okay, so maybe this is a little bit more abstract, but this is the how. So I mentioned before that oftentimes we have this really, really granular understanding of energy in Ireland, 36 sectors, 34 energy subtypes, but oftentimes that's kind of, you can't see the wood for the trees. So we also do an analysis called modal analysis, where we break it down into 3 high-level sectors. So we look at electricity demand across the country, we look at transport demand across the country, and we look at heating and cooling, because that's essentially what energy is used for. It's either used for electricity generation or to provide electricity for moving goods around, and the other thing is just really heating and cooling around the country. And these are the three categories that we need to report to Europe on. We need to have a specific renewable energy share in our electricity, in our transport demand, in our heating, and then overall as well. I'll speak to those in a second. Yeah, so you can drop of water. Any questions now while I take a quick breather? I don't mind taking questions on the fly. Yeah, please, if you shout out if I can hear you. Sorry, if you could speak up, please.
I'll take a mic over to you. Hold a second.
And he's just going to come over with the mic, yeah.
So I'd be curious, where are most of the oil imports coming from? So from whom does Ireland actually import the oil from?
So oil is what's called a fungible source. So a litre of oil can come from anywhere. It really just changes on, like we've had periods where we would have had a significant amount of oil from Syria, from Libya, from Russia, but it really just kind of, it varies. So unlike natural gas, we import 75% of our natural gas through 2 pipelines to Scotland. So it all comes from Scotland. Whereas oil is just coming off a boat, and where the boat comes from is really just dictated by supply and market forces. We have no long-term contracts with any specific country. Yeah. Any other quick questions, or I'll pop on? Yeah?
Basically, the transformation losses in making electricity are waste. In other words, if it was made by CHP, combined heat and power, or by using the heat co-located into district heating or into drying or some other process that needs heat, then that waste would be stopped and the CO2 waste would be stopped. And is there any reason why we should build more power stations that are going to waste 45% of the CO2 that's put to them when it could be done into CHP and it needs to be pushed?
Yeah, so that's a great point. So I guess the technology for generation has improved. Now there's recirculation technology where the hot exhausts are brought back in to try and eke up that percentage. But heat recovery through district heating projects or through greater use of CHP do make sense. So CHP is just where you are generating electricity, but the waste heat you take and you send to a swimming pool or you send for some use. The challenge there is that transporting heat can be a little bit of a challenge. So you need to kind of build your CHP like as an anchor supply near a hospital or a school or something that can kind of take that heat. But it's a great point. Oftentimes I reflect, there's that movie that was out recently that is everything, everywhere, all at once. So the targets for Ireland are so ambitious that we need to be looking at every option on the table. Yeah.
One other question.
Yeah.
How much could anaerobic digestion produce of gas, methane gas, from the food waste in the country if it was all put to the food waste? And how much gas could we collect from the slurry tanks that are wasting methane as well?
So I don't have that number off the top of my head, but I know that in July of last year, the government published a press release which accompanied the sectoral emission ceilings, and it included specifically a paragraph on aerobic digestion and what the targets for out to 2030 are. So if you want to come up to me at the end of the talk, I'll direct you, but I'm afraid I don't have those numbers off the top of my head. Great. Perfect. So really, we have this kind of headline number. Ireland is looking to reduce its greenhouse gases by 51% by 2030, and it's 2023. We're ending Q1 of 2023 right now. So there's this massive ambition, and we have these kind of carbon budgets and these sectoral ceilings, and they're really useful tools for breaking down this monumental job of getting a 51%. So the carbon budgets tell us when we need to make those changes. The carbon budgets dictate a time profile to get to that 51%, and the sectoral emission ceilings they provide, they tell us where in the economy that those reductions need to be made. So again, so we have to bring our greenhouse gas emissions down by over half relative to 2018 levels by 2030. And this is just a snapshot to kind of give an idea of where CO2 is coming from. It's a slightly longer baseline just to kind of show where we've come from, really. But if you look at 2005, which is going back a fair bit from this now, Ireland was emitting over 70 million tons of CO2 every year. 64% of that was coming from energy, and 29% is coming from agriculture. But if you jump forward to 2021, what we see is we've knocked off 10 million tons of CO2 from Ireland every year already. So we are well on this path to reducing emissions. It's not something new that just appeared, and we need to kind of get it there for 2030. The interesting thing here is that in that time, all of that saving essentially is coming from energy. In fact, agricultural emissions are going up. So the reduction that Ireland is seeing is the reduction from energy and it carrying increases from agriculture. So that's really why it's important that all sectors of the economy, they have a role to play and a responsibility in reducing the emissions. So I'm not kind of calling out agriculture or energy in particular, but it's an interesting plot to see that perspective of where the changes are coming from. And even though we might be seeing national reductions, some sectors are increasing, and that kind of can't go on going forward. And that's what the carbon budgets are there to do. They hold each sector to account in a fair and equitable way. So, as I said, the three binding, and they are legally binding carbon budgets. They're not notional, they're not aspirational. They're something that the country has to achieve from a legal basis. Here they are. They're broken down into, over the next, I guess, 13, 15 years. And we have these binding sectoral emission ceilings as well. So we have 7 or 8 areas that are being selected, and we cut the economy up into these different sections, and different targets have been allocated against those sections, again, in a fair and equitable manner. So again, I'm just going to hammer home this point. So even though 57% of emissions in Ireland are coming from energy, many sections, it's all energy. So all of the savings need to come from energy savings, either by making the energy more renewable, less carbon intensive, or just using less energy in the first place through efficiency measures. So we developed for the Energy in Ireland report back in December this nice, I hope, a nice panel to help explain the carbon budgets and the sectoral ceilings. These bubbles here kind of give the size of the carbon emission from each sector in 2018. It's the baseline year. This section shows in total what each sector can emit in total in the 5-year period of the first carbon budget. So again, agriculture can emit 106 million tons of CO2 and stay within its carbon budget, whereas you look at electricity, it has to stay within 40, for example. The carbon budgets also specify something called an end-of-year indicative emission. So this is this shows what the emission should be at the end, the annual emission should be at the end of the 5-year period. So for example, electricity, which was emitting 10 million tons of CO2 in 2018, that needs to come down to 6 million tons in, say, 2025 to kind of be on that indicative trajectory on the way down. Transport needs to go from 12 to 10, residential from 7 to 5, etc. And when you look at then to 2030, that's only 2025, right? So it's 2023 now, so 2025 is only in 2.5 years. 2030 going forward, you see these massive reductions that are required of electricity. So electricity was generating 10 million tons of CO2 in 2018, but by the time we get out to 2030, it needs to be down to 3 million tons. And also all projections indicate that we'll need about 50% more electricity. So we need more electricity, but we need that electricity to be generated with substantially less CO2. So again, plots like this are kind of useful because they kind of allow you to zone in on exactly the change that needs to be met. I really like this plot. I think there's a lot of information there. Would anyone have a question about it, or because this is the core of kind of getting Ireland's emissions down. This is the timeline and the sector breakdown. So kind of almost everything you need to know and we're afraid to ask about reduction is here. So I'm more than happy to take any open questions if you have them. Yeah? Yeah, thanks a lot.
Thanks very much. It's really interesting data. It looks like proportionally agriculture doesn't have to cut that much compared to other sectors. Is that essentially a political decision, or is there another reason why? Is it too difficult to cut emissions in agriculture compared to other areas?
So I think government engaged with all sectors to try and understand what's achievable and like what can be done. So the targets are different for different sectors. I guess when you offer different targets to different sectors, there's always going to be somebody who has the highest and always going to be somebody who has the lowest. But I guess it's that difference between something being fair and being equitable. So you could just say, no, everybody needs to lob off 25%, or you could take maybe a more nuanced approach that some sectors are better positioned to make reductions. So for example, when it comes to electricity, we kind of know how to decarbonize electricity. I mean, I'm simplifying hugely here, but like more renewable generation, offshore wind, onshore wind, more storage to kind of take kind of winter generation and bring it into the summer months. So it is in no way a solved problem, but there is a well-defined pathway there. Whereas if you're looking at agriculture, the pathway to decarbonization is perhaps less clear. So I think that's really how those things were divided. I'm not sure if hopefully that's not too equivocal and to dodge the question. Yeah, Gabe? This isn't the plant. Gabe works in the Marcoms team, but it's not a plant, yeah.
Hi, Lee. Thanks for the presentation. Is there any indication yet if we're going to meet our targets by 2030, and if we're not going to meet them, by how much?
So this is where I can comfortably say the stats team, we look at the past and we leave all future projections over to Emma. I actually do have some slides at the end which show how we're doing. Actually, I might just click in. It's actually this slide, so I'll just jump in. These are the trajectories that we would need to be on top of to get our transport and our electricity down. These grey bars are how we did in 2021 using our definitive data, and the shaded bars are how we think we are doing with our provisional data. So what this shows is actually, and this is maybe slightly counterintuitive, is that we're actually slightly behind we're slightly below budget on transport, but that's entirely due to COVID impacts. So 2021 was still feeling a COVID impact. So you wouldn't want to be getting too comfortable with that low range here. We know it's going to go up. So right now it's very kind of hard for us to tell because we're only on the first 2 bars of a 5-bar story. Electricity though, it's not looking amazing. Admittedly, this is our provisional data. We're still calculating the definitive data for 2022. I know people sometimes are frustrated that it's March 2023 and I can't yet definitively tell you what happened in 2022. But it is quite complicated to piece the puzzle together of all the different supply, the rooftop solar we have to take into account, the farmer solar. It takes some time to pull all the numbers in. But the interesting thing is that these annual trajectories, they're not binding, but the total is. So what it tells us, if it is true that in 2022 we overshot on electricity, we have to be more aggressive in the later years. So it's kind of like having money in the bank or pocket money, and you're spending your pocket money too early in the week. You need to live within our means, and that's I guess something that's really why I like the word budget and the carbon budget. We're used to living within our financial means. We'd never really have maybe thought about kind of our carbon means, but we now have a carbon budget, and if you blow your budget, it's like blowing your financial budget. You're in trouble. Yeah. Gabe, yeah.
Thanks, Lee. A really great presentation so far. I suppose your response to Anya's question actually kind of fed into, or maybe answered the question that I had just about projections. You mentioned Emma, that would be maybe more her territory. But I just wanted to know with data modeling and based on, say, public policy making for decarbonization of different sectors, can you see, and again, you can say, again, this may be more a question for Emma to answer, but considering those, can you see sectors whose pathway to decarbonization is more viable based on, say, using, say, data modeling at the same time as, say, what the government is talking about in terms of, say, certain policies for certain sectors, for example, potential congestion charges, in urban centres for transport, another policy for agriculture, and so on and so forth, if that makes sense?
Yeah, so it's a great question. So Emma and her team do, to me as a statistician, sophisticated modeling. So it's not as if they look at the last couple of points and kind of draw a line that the trend will continue. They take in econometric data, population data. They take in policies that are in play, existing policies that might come into play. So they kind of would run multiple scenarios depending on what way the wind might blow, and then they look to see how Ireland's projections would fall out. And that's feedback into policy. So basically, Em and her team are able to tell the government, like, kind of, if you don't do this, then electricity maybe won't get to that level or so. The reality is, I mean, I'm delighted that I look at the past, because predicting the future is a nightmare, really. And things like planning permission or regulation change can have huge impact on if you're trying to build more, renewable, wind generation or offshore. Like, kind of at the stroke of a pen, something that looked like it was going to be on track can kind of change very, very quickly. So the projections are susceptible to the realities. Whereas in the stats team, like, we're always looking at what's happened. So it just happened. So we're really kind of doing accounts and measuring the past. It's a pity that Emma couldn't join us today, but I have her email address up at the end. So if you have any questions about her projections, she'll be happy to answer. So okay. I guess I'm going to move on now from the carbon budgets. But if there are any other questions, I can take those at the end. So again, yeah. Oh yeah. Yeah. So go ahead. Yeah.
Thank you. This is quite a layman's question, but what does a budget deficit look like for the industry or for the people of Ireland? So, as you say, you spend your pocket money, you run out, you're out of money. A deficit looks like debt. You have no more to spend, you have to go and get it from somewhere else, you have to pay more for that. What does a deficit look like in terms of energy? Do the lights just go off? Or is it just we pay more?
Yeah, so there are means within Europe. Within Europe, there's like an emissions trading scheme. So it's like cap and trade. So if we go over our carbon budgets, we kind of need to buy that, like, carbon relief off from government. But essentially that falls on the taxpayer. So really, if Ireland doesn't kind of meet its carbon budgets, there's a financial cost to everyone who's paying taxes and the opportunity cost of that. Having said that, the EU is sometimes more forward-thinking than we give them credit for. So the government can commit. So instead of just handing that money out, they can ring-fence money for additional renewable energy, and that's okay. So you can kind of buy credits with a commitment to build more renewable energy, for example. So you're not just kind of throwing money out, it's kind of circling back in to solve the problem. Yeah, it's all, I mean, we haven't, like, it's all fairly new, but like that's really the essential legal basis for it. Yeah, great. So as I said, there's a huge national focus on the national carbon budgets, but they are national targets. Before that, we've been living as well with renewable energy targets from the EU, both nationally and from the European perspective, some of which are binding, some of which are non-binding, but there's plenty of European targets that haven't gone away because we've suddenly become very interested in carbon. So under RED 1 out to 2020, we had to meet renewable energy share targets for the overall renewable energy share of Ireland. It's about 13.6%, spoiler alert. The renewable energy share in electricity, transport, and in heat. But things changed last year in 2021. So the RED 2, or the Renewable Energy Directive Mark II, came into power, and it's different from RED 1. So not only are we kind of moving into a world with carbon budgets, how energy is kind of results are measured and targets are set in Europe has changed at the same time. So there's a huge amount of change in the regulatory and in the statistical space, all happening at once. So when it comes to the renewable energy shares and RED 2, I guess the two key points for Ireland are that there is a formal verification required on biomass. So it's not enough now that biomass exists and you say it's renewable. It has to be mass audited. So it's kind of, you need this label that goes with it to prove that it is real renewable biomass. You're not kind of cutting down forests and burning wood. It has to be kind of from managed and certified sources. And I guess something that's surprisingly, or for me, it came as a bit of a surprise how important this is. But there are caps on the types of biofuels that we can include in our renewable energy share of transport. Yep. Go ahead.
Food waste be included as a renewable biomass? If not, why not?
So, if it's certifiable if it's certifiable, yeah, that's not an issue. Yeah. Again, it would be around kind of collecting sufficient quantities, I guess, handling it in a lot of you mentioned before about the anaerobic stuff. So, I mean, if you've ever visited an anaerobic farm, it smells like kind of gone off yogurt, because they feed these things with waste foods like yogurts and petit falou and cheeses. And so I guess waste foods are already existing as biosources into the energy system. Yeah. So, I mean, there's no real, so again, the EU legislation is never trying to push anything out. It's just that, it can't be done on a wink and a nod that this is renewable. There needs to be kind of an audit or something behind it that proves that it is countable towards the target. I'm not sure if I that.
The point is this, that I believe there's a lot of food waste that is potentially a source of methane that is not being harvested for the methane, and therefore, if it is allowed to be called a renewable, then it's really of great value to the country. Because when people normally talk of renewables, they're thinking of something that's taking up extra land to grow wood or whatever it is, or grass or whatever for the plant. Whereas food is already grown and it's sitting there and it's producing methane if you dump it. And why not collect it and have it as a renewable? So
I'm not aware of any limitation on that. I guess it provided it's commercially viable, because the electricity plants they're operated through. So there's somebody behind you, I think, who can answer your question. So I might have dodged a bullet.
Yeah, I'm actually in the business of making energy out of food waste. So you're quite right. There is lots of food waste around, and it is turned into energy. Not all of it gets turned into energy in Ireland, but more of it is. Not all of it's collected, but more and more of it's being collected, and it's going into biomethane, that's for sure. And there's quite a rapid kind of development in that area going on at the moment right now.
Great, that's great to hear.
It goes to produce electricity for the general electricity demand, or for certain electricity consumers, and also into the transport sector as renewable gas for heavy goods vehicles.
Well, that's great to hear. So yeah, thanks. I hope that maybe goes some way to answer your question as well.
Your statistics for next year as to how much it could be.
Yeah, sure. I'll give you your email address and I'll put you on the mailing list, no problem at all. Yeah. So one of the, I guess perhaps this is related. So it might surprise people to know that we use a lot of, because when people think about renewable energy, often they're thinking about shiny things like beautiful solar panels or wind generation, but things like used cooking oil and animal fats make up a very substantial fraction of our biodiesel, and RED II puts caps on that. So there are concerns in Europe that non-renewable oils are being imported into Europe and are not really renewable. So to kind of safeguard against that, RED II puts caps on it and has a strong impact on Ireland's success against its renewable energy targets. I'll kind of just look at the overall value just for a moment. So in 2022, 13.6% of Ireland's energy was renewable, be that wind, hydro, biofuels, biomass, etc. In 2021, that went down to 12.5%. So we saw a reduction in 2021. There's reasons for that. Mainly, I don't want to dismiss it, but it's mainly related to the accounts change on going from RED I to RED II. As I said, things that were countable in RED I are capped or limited in RED II, and that puts downward pressure on the results. So if we were able to calculate 2021's results using the old rules from RED I, we would have actually been constant. We would have had 13.6% in both years. But under the new rules, that's gone down to 12.5%. The overall results for Ireland are very ambitious in this area. So we're looking to get up to over 34% renewable energy, over a third of all energy in Ireland being renewable by 2030. And Europe as well has put in these milestone years, because 2030 is kind of almost a decade away, so it's a little bit easy to kick the can down the road. So to try and stop that happening, there are these targets, there are these milestone targets out to 2030 that we need to hit. We are meant to remain above our 16% baseline all the way out, and then hit a target of just under, I guess, 19% in 2022. And that's the trajectory necessary to get us to the 34% value in 2030. So, I mean, these numbers here, like, let's be honest, this requires a step change in how we're doing things. It's clear that, like, just linear increases or incremental increases aren't going to cut it. We need to more than double our renewable energy share in 7 or 8 years. It requires step changes in how we use energy, how we generate energy, and the efficiency with which we actually use that energy. When we're looking at electricity, the story there is a little bit brighter. So in 2020, we reached 39% renewable energy share. Our target was 40%, so we just missed it. Again, going into 2021, which is the last year that we currently have definitive information, the rest of my team are back in the lab working on 2022's numbers as I speak. But again, we saw a slight reduction in 2021 compared to the previous years. 2 reasons. Again, the new accounting rules in RED 2 mean that biomass that's used in power plants that isn't verified isn't countable. It's not as if it doesn't exist, but we can't count it because we can't prove that it was renewable. And we did have a bad wind year in 2021 as well. So the combinations of those 2 effects drove down the renewable energy share to just over 36%. The ambition under the National Climate Action Plan is 80% renewable energy by 2030. So again, very, very significant increases needed to achieve that ambitious target. And transport, which I alluded to just a moment ago, is probably where we see the most strong change from the accounting or the regulation difference between RED 1 and RED 2. We had just over 10% of renewable energy in transport in 2020, but that falls to 4.3%. 4.3% in 2021 because of these strong caps on UCO and tallow in our biofuels. So if we were able to count again, if we were able to do the 2021 numbers under the 2020 rules, we'd be more or less the same. It would go from 10.1 to 9.9. But the RED 1 to RED 2 transition has had a huge impact on our renewable energy share target, result rather. And I mean, it goes without saying that if we're trying to get from 4.3% up to 14% in the next 7 or 8 years, again, we need fairly radical changes in the renewable energy and transport. We need, I guess, more use of, public transport. I mean, there's this, modality change, so cycling, walking, buses, trains. The cars that we do use need to either have an increased biofuel share or increased EV, an increased percentage of EV in the national fleet. So maybe I went through that rather quickly because I just know that I'm running out of time, but are there any quick questions before I do a very, very short wind down? Yeah?
Well, I'm very much involved in the whole transport area and in the change of accounting under RED 2. What a big issue in all of this is that this cap on used cooking oil and tallow came in, but without changing the quality of the used cooking oil and tallow allowed. And in fact, we'd have done much better if we'd applied some kind of qualitative criteria on what we used rather than simply ratcheting down the volume. Because ratcheting down the volume means we could end up with the worst quality surviving and the good stuff not surviving. And in fact, we're in a very heated battle with the government this week over that. So we're seeking improvements in the quality without that drastic reduction in the quantity. And I don't know if you'd ever like to talk about this afterwards.
Sure. I know that there's kind of conversations going on between Irish government and the European Union on a kind of a derogation of the cap because
it's not going to happen.
We're not. The cap is there to kind of stop to safeguard against imported, say, tallow or UCO, but Ireland produces a lot of its own and can stand over more of it.
Yeah.
So I know you might be more plugged into that conversation than I am.
You're exactly right, yeah. We can stand over it if it comes from Europe in general, yeah.
Yeah.
The other point I'd make, referring back to the gentleman's comment on anaerobic digestion, the other kind of big ask of the sector is that we do carbon capture from the anaerobic digestion system because it's the easiest, cheapest way of capturing carbon. And then we just need to look for a place to store it, which is actually not such a difficult thing at all. So I'm hoping the SEAI would embrace that particular theme as well.
Yeah, so certainly. I'm not sure if my colleague Lucy is in the audience or is around, but Lucy heads up the research, development and deployment team in SEAI, and they look at funding projects looking at like innovative solutions in that space. So if you haven't met Lucy yet, I'll make a connection.
Okay.
Yeah.
Thanks a lot.
Great. And I think I'm down to my last minute, so I'm going to power through this very, very quickly. I would just say, and I've alluded to it at the beginning, that traditionally SEAI has looked at national statistics. So everything I've been talking about here has really been about Ireland. But we're increasingly looking at, and we're strengthening our GIS, our Geographic Information Systems team, to be able to produce robust statistics at a national level, which we already do, but to do regional statistics and also community level statistics. So the idea here is that national statistics are critically important for informing policy. Regional statistics are very, very useful for planning. But then when you're producing statistics for communities, and there are these sustainable energy communities, there's about 800 of them in Ireland that SEAI helps coordinate. These are small groups of individuals or housing estates or towns. So we want to be able to kind of bring statistics down to that level, make them understandable and interesting for people to use, and kind of allow them to make evidence-based cases for their communities. And again, these conversations we hope to feed in or hope to influence will be, at the policy in Leinster House, in the local authority, in the planning offices around the country, and in the kitchen tables and cafes around the country as well, with our community level statistics and dashboards. So we already produce a bewildering variety of maps around the country. So if you want to find out anything about Ireland's wind, bioenergy, geothermal, heat demand, hydro, or building energy ratings, I think we launched a new one yesterday, which is around district heating potential. So there's a wealth of information on the SEAI website if you're interested in your area. It doesn't have to be national statistics. You can dive down into statistics that are relevant to your county, your town, your community, etc. We're also providing information to the local authorities. So we have specific dashboards that are publicly available. Anybody can go onto them, which break down, say, the BER ratings or the EV grants or the heat demands of the different local authorities around the country to support them in the generation of their local authority climate action plans. But they're also really interesting, and we designed these things to be easy to use. They're fun, interactive dashboards. If you're interested in your area, go in and see what you can see. You might find something that jumps out at you or surprises you about your area in terms of its energy supply or demand. And again, we're breaking it down, not just country, not just county, but like we're doing energy statistics on, say, Trim, because Trim are a sustainable energy community, and they want to have evidence-based information when they're developing community action plans. So again, the idea is to kind of go down smaller and smaller, and the different information at these different levels of disaggregation are useful to different conversations, and in the stats team, we're trying to feed into all of those conversations. So thanks again for attending. I think I'm 2 minutes over time, but I'll take any follow-up questions. Yeah, thanks. Any burning questions, or did I get to most of them during the talk? Yeah, please.
Sorry, I know it's more for the other team, but instead of your team, but just in making predictions for the future, like you were talking about, sometimes the wind doesn't blow as much as, in some years as others. And, the planning applications can, for renewable energy, wind farms offshore can be stumped in planning for years. So how do you, model that in, or your colleagues model that in? There must be so many kind of notes saying, but this is dependent on X, Y, and Z, and therefore does it make, how can it be honest in its predictability, I suppose?
Yeah, so certainly when it comes to like timelines or so I think there's people say maybe it takes about 9 years to kind of get an offshore wind in place from the moment you kind of think about it to get the planning and the technology in. Those timelines are kind of known and are realistically modeled. So it's just known how many years these things will take place. When it comes to the wind, I'm going to guess they use median, or they might do 95% confidence ranges. But we do have years, like 2021 was a bad year for wind. I think wind was down 17%, and like it was just a bad year for wind in that sense. I mean, things like security of supply or energy storage are critical to address intermittency of the renewable sources. So there's two issues with wind, not issues with wind, sorry, I check my language now. With wind, it's intermittent. So even when it's windy, it can be up and down. And there's a really pronounced difference between winter and summer months. So we produce twice as much wind in the winter as you do in the summer. So what you need to be doing, people talk about seasons to seconds. You need to have stability in renewable or electricity on the second level, but you also want to be able to shift that, I don't mean excess of wind, but this large amount of wind we generate in December and January, and bring it into the kind of the lull of July and August. So that's a kind of a storage problem. The other thing would be around compensating with solar. So sometimes people kind of look down their nose at solar because they say, oh, Ireland's not very sunny. But the key point is that solar is strong when wind is weak. So in the summer months, the solar is at its peak, and in the winter months, wind is at its peak. And if you're kind of clever in balancing the national stock, you can kind of smooth things out, and that really reduces the challenge then for seasonal storage. But the intermittent, so there's two problems: the intermittency, short term, and seasonal variations. But really, I can't speak in detail, but I know the modeling team, it's world class, the models that they generate, subject to peer review and all that. So I'm sure they're taking all reasonable effort, all superhuman efforts to try and bring those considerations in. Great. I don't want to overstay my welcome because I think somebody else is coming on next, or... Oh, no, okay, I'm not getting the sign. Any last final questions, or? Yeah, please.
Hi, thank you for your presentation. And I don't want to put you on the spot with this, but is our transport targets over ambitious by 2030? I know there's about a 30% target for electrical vehicles to be in place, and that's in the private fleet. But I think one of the things that's been overlooked is the infrastructure that follows that as well. With an increase of 30% of electrical vehicles on the road, the infrastructure behind end-of-life vehicles will be a problem. We don't have the facilities for end-of-life vehicles yet, and I think that's something that's been overlooked. I think the target being set by Europe is overly ambitious for Ireland, and I'm just wondering what your thoughts on that is, and how we plan to reach that, especially with electrical vehicles.
So yeah, so there's quite a degree of synchronicity between the targets. So I think it's the 33% we're looking for reduction in transport emissions kind of ties into. So we're trying to, I guess, reduce emissions and increase renewableness at the same, but they're kind of complementary, so they kind of happen at the same time. So I'm trying to spiral into your question. So it's really that the ambition of the Climate Action Plan is kind of what is necessary, kind of according to projections, to achieve the legally binding requirements of the carbon budgets. When it comes to transport, really there's this behavioral change. I mean, the IEA recently did a study that I think only about 60%, or is it 60% of European emissions can be addressed maybe through technology, and 40% needs to be people just using less. So when it comes to transport, I guess we need to see that modal shift away from private car use where at all possible, and onto kind of onto public transport. Where movement away from private cars isn't possible, that those private cars are either on higher fuel blends, are moved over to either plug-in hybrid or battery-only hybrid, or people are making these behavioral changes towards ride sharing and things like that. So they are incredibly ambitious, but that ambition is necessary. I guess we might drop, yeah.
Yeah, I just want to follow up on that.
Yeah.
But the negative output, if we don't reach that target, is the repercussions. It's a massive fine. Am I right in saying?
So I would have to be careful now, because I'm not sure. It kind of requires ring fencing of money towards the solution of that problem. So again, it's not as if we just throw money out to Europe. It's more that Europe has to give Ireland has to give a commitment to Europe that it will use the money it would spend on the carbon credits or so, the trading system, to support or to further enhance the renewable.
And that's at the cost of the taxpayer, yeah?
Yes.
So are we being forced into electrical vehicles then? Am I right in saying that by an EU demand?
No, I mean the targets are there to guide us towards the reductions, and the different targets on different sectors of the economy are to ensure that nobody's let off the hook. So we need ambitious reductions in transport, we need them in electricity, we need them in agriculture. So obviously certain sectors feel, I guess any one sector feels the pinch because they're only looking at their sector. But when you look at it from a national perspective, like everybody needs to, I guess, pull their weight.
All right, thank you.
Yeah, we can maybe if I haven't really clarified, maybe we can talk after. Yeah.
You okay taking one final question?
Well, yeah, one final. Yeah, sure.
I'll take one final question, then we'll wrap up.
Basically, I got an EV because I was fed up being a polluter when I went on a trip in my diesel car, and it was using about 45 kilowatt of fossil fuel per 100 kilometers. So I got an EV which is only using 17. And then I looked up at your website and I found that each kilowatt of electricity has 1.47 kilowatt of fossil fuel in it at the moment. And therefore, I'm only saving from 45 kilowatt per 100 to 25 at the moment. That is why I'm so concerned about the waste of in transformation losses.
Yeah, so as I said, right now, if you charge up a battery-only EV, 40% of that charge is coming from renewable sources, so essentially zero carbon, but the other 60% is coming from a portfolio or another fuel mix. But I guess it's important to realize that, like, in 2030, 80% of the electricity will be renewable, and then out to 2050, perhaps all of it will be. So we're on that journey to making the electricity more and more renewable all the time. So it's literally every month your EV is getting more and more renewable as it goes. And I guess what's kind of critically important as well is that if people are kind of on the cusp of buying a car, they're kind of locked into that car for 15 or 20 years. And what we want to have is that people are making that 20-year commitment to their vehicle towards a source that will get more and more renewable, like electricity, versus a source which is not going to get substantially more renewable, like petrol. I mean, we've gone from 5% biofuel mix to 10% biofuel mix. Still 90% of the petrol in the forecourts is pure fossil fuel. So again, for me, it's a no-brainer that if you are making that decision to buy a new vehicle and you can afford it, to go for an EV, knowing that it gets better every time. Yeah.
Excellent. Thanks, Lee.
Thanks a lot.